viewers, my name is Darlington Okoka and I welcome you to Delwit Electrical YouTube channel. In this episode, I'm going to take you to a concept called voltage divider rule. Voltage divider rule is appropriate mostly for a series connected circuit. This helps you calculate the voltage across a resistor. So instead of going through this rigorous process of calculating what V1, V2, V3 is, we have a rule of thumb that helps you calculate instantly what the voltage across each node is. So it's called a voltage divider rule. So we've agreed that the voltages across every resistor decreases across the line. So the voltage is not constant, unlike the current that is constant. So how are we going to determine the voltages across each resistance? From Ohm's law, we know that V is equals to IR. That's our first principle from equation 1. So from our previous circuit, let's now see how we can get our voltage divider rule. Now, we know that V is equals to IR. Our R now is our equivalent resistance, which is the resistance we've gotten across all resistors. For series circuit, we have R1 plus R2 plus R3. So our V is equal to I in bracket R1 plus R2 plus R3. That gives us our equation 5. I now is equal, if we make I the subject of the formula, we're going to I equal to V over R1 plus R2 plus R3, which is equal to V. R1 plus R2 plus R3 is R equivalent. That means I is equal to V over R equivalent. That gives us our equation 6. Now, if we substitute our equation 6 into our equation 3, which gives us our individual voltages V1, V2, and V3, we will have our V1 from equation 3 is IR1. So V1 is equal to R1 in bracket I, and our I is equal to V over R1 plus R2 plus R3, which we agreed is equivalent, R equivalent. Therefore, our V1 is equal to R1 over R equivalent times V. In that same order too, we're going to have V2 is equal to R2 over R equivalent V. Our V3 is equal to R3 over R equivalent V. I believe you understand what I'm trying to say. So for every voltage divider, no matter the number of resistors we have, R1, R2, R3 to R1000, no matter the number of resistors, in as much as they are in series with the voltage source, the nth resistor, Vn, which is the voltage drop we're trying to calculate across that resistor, will be equal to Rn over R1 plus R2 plus R3 till the R equivalent, which is the Rnth, which is equal to the summation is the R equivalent times the source voltage. I don't know if this is appropriately understood. So I'm going to give you an example of this circuit here, whereby we have a source voltage 12 volts. We have resistor. Our R1 is 1 ohm, R2 is 2 ohms, R3 is 3 ohms. So since they are connected in series, our R equivalent now will be equal to R1, which is 1, plus R2, which is 2, plus R3, which is 3. So 1 plus 2 plus 3 will give us 6 ohms. From equation 7 that we have above, we can see that V1 is equal to R1 over R equivalent times V. Our R1 is 1. Our R equivalent is 6. Our V is 12. So 1 divided by 6 times 12 will give us 2 volts. So our V1 is 2 volts. Our V2 now, from equation 7 above 2, is R2 over R equivalent times V, which is equal to 2. Our R2 is 2 ohms. 2 divided by 6 times 12, which will give us 4 volts. Our V3 from equation 7 is R3 over R equivalent times V. Our R3 is 3 ohms. 3 divided by 6 times 12 will give us 6 volts. So you can see that the voltage drop is additive in the total, which is the total equivalent of the source voltage is equal to the voltage drops across the resistor. If we add 6 and 4 and 2, which is our V1, V2, V3, it will give us 12 volts. And our 12 volts is the voltage drop, and our source voltage is 12 volts. So you can see that the voltage across the circuit is addictive. So I believe this topic we've treated have been very educative. If you have any questions, feel free to comment on the comment box, and be rest assured that I would attend to every question on the comment box. So please click on the subscription button to get notified on whenever new videos are being posted.